Tonight's jobs have been finishing off the little lamp for the sandblasting cabinet. I 3D printed this cover just to go over the main socket on the back to protect all the wiring and so I don't electrocute myself, but that works really well now. So that's all done, and I fitted the studs and nuts to the rear half shafts, and I've given those a coat of paint on the back. I need to turn them up the other way and paint the front as well, just for some rust protection. I'll probably give those another coat tonight. I'm running out of paint actually, so hopefully I've got just enough to do that. And I did the same trick as I did on the fronts, which was use Loctite retaining compound around the actual studs themselves and the holes, and then Loctite on the nuts as well. And then they were done up with my biggest breaker bar to as much torque as I could put on them, really, without going mad with long levers. So those are done. These do have a little scroll machined in the end of them, so you do have to make sure you get the handing right, which I'm pretty sure I did. 50-50 chance. The other thing I did was this is a test assembly of the new crown wheel and pinion. I haven't put in all the lock washers and things like that yet, but it is all bolted up tight. I did have to carefully just sort of polish the inside edges where it fits into the bearings, just to make sure there weren't any burrs or anything, so it would fit into the bearings. And I did my usual trick of heating up the bearing housings in the little oven, so it was easy to just tap them into place. What I have now is the whole differential assembly set up on V-blocks as per the manual and the instructions that you can find, some of the articles and things printed over the years. And what I'm checking for is, with the new crown wheel bolted up in place and this running in its bearings, what the run out on the crown wheel is, and it needs to be less than 2 thou, which it does seem to be. It seems to be just on 2 thou, so that's good enough. I've measured it in multiple places across the back there to kind of average out the readings, because you have to be careful you don't get little localized bits of dirt or small defects in that machined surface upsetting your reading. So I've done that now, and that all seems good. I should be able to disassemble it with the bearings in place, hopefully, because getting those off again would be a real pain in the neck now. And I will bolt this all back together with the locking tabs. That's all of these came from the spares. They've probably just been plasma cut or laser cut, so I can put those in place and hopefully start getting the rear axle back together. The other job I had to do, so I can do that, was fit the bearing on the pinion shaft, and also fit the new muff coupler and the little locking set screw and the locking ring. The screw didn't actually come with the new muff coupler. I probably was supposed to order that separately. The pinion shaft actually has a sort of slot in it, and the inside of this little screw is machined down. It's sort of stepped, so it fits into that slot, and that locks it in place. And then you can see the ring sort of fits into the slot in the top of the little grub screw, and that stops it coming undone. So before I did all of that, I did do a quick measurement, just a sanity check to make sure when this does screw into the back of the torque tube, this is actually going to match up with the end of the drive shaft. So that's all looking pretty good. Hopefully I'll be able to do that job in the weekend. Once I get the differential in there, I'm going to have to do the setting of the backlash and the setting of the crown wheel in relation to the pinion, and that's always a little bit fiddly. I have done it before. I believe I did it on my MGB when I restored that. I definitely did it on the Austin 7, so I have got some idea. I do know it's not quite as easy as they sort of make out in the books, in the manuals. So this is like the classic drawing of where the wear patterns and things are supposed to be. You're supposed to use sort of Prussian blue or paint or something like that to match this pattern. It doesn't really look like that when you're actually trying to do it, or at least it never has for me, so I always find that quite difficult to do. But I'll give it my best shot anyway. I did, as a test, measure up the differential that came on the parts car, which is a slightly different style of diff, but I got pretty much exactly the same reading I get with this one when I was measuring the run out. So assuming the first one is correct, then this one is correct as well. Interestingly, with these things, it's one of those things where they never say what to do if it's wrong. So with the Riley one, they do say if it's more than 2 or 3 thou, try the crown wheel in a different position on the base, and make sure it's absolutely clean, of course, so there's no little bits of grit or anything holding it, stopping it from seating correctly. But I've never seen it written down what you're supposed to do if it's way more than that. I guess back in the day, buy a new one. But what would you do these days if you're building a car from parts? How would you fix it if the crown wheel and pinion are too far out of whack? And I'm guessing all you could do would be remachine the face. How you would set all of that up, because you'd have to set this all up so it's accurate and true, and I don't know how you would do that. I've never seen it explain what you would actually do in the case that it's out of tolerance. And then the other thing is, I'm not sure what happens if these are out of tolerance anyway. They definitely get noisy. I think that's the biggest problem, is they'll make an awful lot of noise. I'm assuming you'll also get the incorrect sort of wear in the thing, but of course that's going to take many, many, many miles of driving, I would think, to actually make a difference. Because I have seen these where you can see where it's all actually worn out and the pinions are all worn out, but they would still work. And that's the thing, it'll work, but it'll just be horribly noisy. And then you have to think, well, okay, that's going to be far worse in a closed top car, for example, than a completely open, effectively race car like this with you know, a gearbox with straight cut gears in it and that kind of thing. How much noise is acceptable? It's really hard to know. So that's why my approach is just build everything as close to tolerance as I can and hope that it's correct. And then realize, well, you're not really going to know until you actually get the car on the road and it's running. So I'm happy with this. This is good enough. I am busy screwing the pinion gear, which I've completed, done up all the lock washers, put the safety rings, all of those things are all done now. I've greased up the thread here. I ran a thread file around it just to make sure there weren't any burrs, and I'm using a screwdriver as a wedge in the slot here to help squeeze it apart to make it easier to screw this in, and there's still quite a way to go. I believe there is a proper tool that they used to use at the factory that would engage with these slots, and if I really have to, I could make something that I can use in the same way, but so far I've been able to screw it in by hand, and now I can drop a screwdriver in here and sort of lever it around. It's not tight at all. It's going to be interesting to see how long that lasts and how far I can get it before it binds up, and I'm not sure how far in it actually needs to go. I think these little holes need to be about midway, so I've got a little way to go. When this is finally all back together and locked in place, there's a pinch bolt that goes through here, and apparently there's a leather gasket or washer that goes in here to stop any leaks from that. So I'm going to continue with this and see how far I can get. I am busy screwing the pinion gear, which I've completed, done up all the lock washers, put the safety rings, all of those things are all done now. I've greased up the thread here. I ran a thread file around it just to make sure there weren't any burrs, and I'm using a screwdriver as a wedge in the slot here to help squeeze it apart to make it easier to screw this in, and there's still quite a way to go. I believe there is a proper tool that they used to use at the factory that would engage with these slots, and if I really have to, I could make something that I can use in the same way, but so far I've been able to screw it in by hand, and now I can drop a screwdriver in here and sort of lever it around. It's not tight at all. It's going to be interesting to see how long that lasts and how far I can get it before it binds up. And I'm not sure how far in it actually needs to go. I think these little holes need to be about midway, so I've got a little way to go. When this is finally all back together and locked in place, there's a pinch bolt that goes through here, and apparently there's a leather gasket or washer that goes in here to stop any leaks from that. So I'm going to continue with this and see how far I can get. I have the pinion screwed in quite a long way now, to the point where these holes are fairly much midway in the housing, and the thread looks most of the way in. I got worried about bending my screwdriver in the end, so I machined up a little sort of Tommy bar out of some high tensile steel. Made that a nice fit in there, so that works really well for pulling that round. I decided before I go any further, I'm actually going to put the differential in and see how far away I am from it all meshing up. But before I can do that, I have to fit all the lock tabs. So I'm doing that now. What I'm going to do is fit all of those but not bend them up. I'll do another check of the run out just to make sure it's okay. I'm not actually taking this apart again, I'm just taking the bolts out one at a time, covering them in copper grease, which is probably completely unnecessary given this is rotating in a bath of oil, but I figure it's not going to hurt. You do have to watch these little crown wheel bolts because the heads are not actually symmetrical. You can see there's more of a flat on one side than the other, and that's so that they'll go in and actually clear the little step on the inside here, so don't try to get them in the wrong way, they won't go. These are the lock washers that go on there, so it looks like I will have to bend up some of them just so I can get these other ones to fit by the looks of it. These ones here hold the two halves of the differential together, so it's actually okay for me to bend those ones up. I think that should be fine. It did actually, the set did come with little single, those are my rear half shafts painted. It did come with these, so maybe, are these supposed to fit on there like that? Because there's 4 of these bolts, so I could use these little ones at the top and the bottom, but then you've got an odd number for these, so I'm going to bend these ones out of the way and just see how that works. The other thing is I could put the tabs on the other side, of course, but I think they're supposed to go this way because otherwise it'd be very difficult to get behind there and hammer them in place. The reason I had to take these off in the first place is because the tabs were on this side and the new crown wheel wouldn't fit over the tabs. Before I did the final hammering over of all of the little lock tabs here, I did another measurement of the backlash and got the same reading. I actually used a different DTI as well just to really double check, and that showed me about 1.5 to 2 thou run out, which is good. I gave all this a good clean. It's still leaking stuff everywhere, and I've got it now in the housing, which is a little bit tricky because these two saddles are threaded and these adjusters are threaded, so the adjusters get pushed all the way onto the diff housing. They're pushed hard home, but they can rotate, which means when you're trying to fit this back into the housing, you kind of have to rotate one of them until the threads are in the right place, and then it sort of just drops into position. But it's quite hard to get it sort of hung up just a little bit. So I think I've got it in the right position now, and that's just pushed home. None of the nuts are on the ends holding it, and I can see, I think the initial setting it says to do is make the pinion gear, the edge of the pinion gear flush with the inside of the crown wheel, and that gives you a starting point, and then you start setting your backlash from there. I think the pinion needs to go in just fractionally, and then I can start adjusting things, but just fit it in by hand. This does rotate. It's binding up in a couple of places, but at the moment there's no backlash. It's actually laser etched on this, or etched on the back of this to say 5 to 7 thou backlash somewhere. Be very careful you don't jam your fingers in this bloody thing as well. There we go. So that's the backlash there, 5 to 7 thou. I've never actually understood exactly how you're meant to measure that. I have some shim steel, so maybe I can wiggle a piece down inside there to see if I can measure what it is. But that's looking pretty good. I think that'll be a job for tomorrow, actually going through and setting all of this up. And I did work out in the end where these other extra lock tabs go. I suspect they are to go on there, so when you put the nuts on you can lock these in place, those in place as well. Obviously you absolutely don't want anything coming loose inside here because it's just going to mangle everything. These are the set screw holes for locking the adjusters, which would mean I'd need to drill, once they're in position, I could drill into the thread in these to provide a hole, and then I'd probably turn up on the set screws little points or something to lock into those. Somebody did suggest to me in one of the comments that they made steel brackets, sort of lock tabs like these, that went underneath here and locked over this to stop these rotating. So that may be something else to do as well. I'm pretty sure once all of this is really tightly bolted up, it's visitors, it's unlikely to move anyway. Shifted the torque tube and differential up onto the bench to make it easier to work on and see what's happening. I've been reading the instructions. This is one of the articles, and it's still a little bit vague. This bit's really good, showing you what the pattern should look like on the teeth. But again, this just talks about it's very important to ensure, and here they say 3 thou backlash. This one, as I showed before, is 5 to 7 thou. So this is the figure I'll use. I still don't quite understand how you're supposed to measure that. You can't really get a gauge down inside there in between the teeth. I'm wondering if you're supposed to do it somehow like this with a gauge set up. This is just a very temporary setup. So there's definitely backlash in there. That's about 10 to 12 thou at the moment. And I can see by adjusting these you can change that. So if I move the crown wheel to the left by screwing each of these adjusters up a little bit, it makes the backlash bigger. And if I screw them in by putting my bar in here and turning them down, of course it makes the backlash tighter. So you have to do that as well as setting this correct pattern. So how you actually measure the backlash, I'm still a bit confused about. I need to go and look that up. I was going to film the rest of this tomorrow, make it one long film. But I'm going to post this up in case somebody's got some suggestions, and you can comment or email me and let me know exactly how this is supposed to be done. So I'm going to leave this for tonight, I think. The only other thing worth mentioning is we went out today and I stopped off at the tip shop and I got a vacuum cleaner hose for $2. And I just sort of rigged up a PVC pipe that's all hot glued in place, and there's just a bit of tape wrapped around it. And that's enough to jam it into the inlet on my vacuum cleaner. So that works well. I can leave that set up permanently, just bring the vacuum over here and plug it in. And the other thing I found was this container full of 1/4-inch BSF. This one, which is also mostly 1/4-inch by the looks of it, quite a bit longer. And this, which is 1/4-inch and something else. These are all Whitworth thread nuts and bolts, which is really good. And the whole lot of those cost me $6. So it's well worth getting. That was an absolute bargain. So I'm quite pleased I found those.